on the computer because I'm told that our cloud is almost full. I also spotlight myself to everyone just for fun. And then I share my screen just for fun because these points are already known. So we said it is because of the revolution of the earth around the sun. But I want to start simply. I want to start with an appreciation of the seasons. What do they look like? So I'm not going to dive into the question of why. I'm going to start with the question of what do the seasons look like? And when do they occur in the different hemispheres? That is the question I'm going to look at. We shall eventually come to across these terms: equinox, solstice, revolution, summer, winter. We will come to them. But the first thing I want us to do today, this afternoon, is to appreciate what the seasons are like, what are their characteristics, and when do they take place. So that's what we are going to be doing first. What are the seasons? Now we know that in temperate lands, there are 4 seasons. We have the season of summer, winter, autumn, and spring. So 4 of them. There is summer, there is winter, there is autumn, there is spring. What are they like? So in the first activity, I'm going to ask you to go to Google. And when you go to Google, open the Google browser, you type the word summer, and I'm going to demonstrate that. And then you look for pictures representing summer. We are going to share them. From the pictures that represent summer, we'll ask ourselves, what does summer look like? So this is how we're going to do it. So I'm stopping this one. I am going to do it first. So I'm going to open my browser. So let me share my screen first. I'm going to open a browser like this one. I go to Google. I hope you guys are able to see my screen.
Teacher, I found it.
Okay, so someone found it already, but let's see if others can find it. So I go to Google, then I type the word summer here in Google. Then I search for summer. First, it has told me summer 2021 will start on June 21st and will end in September 22nd. This is what it is showing me right here. Then I need you to go right here where there is images there for images. And then we are going to see the images of summer. These are the images of summer. We are going to base on these images of summer to describe or to infer what summer looks like. So that is activity number 1. I need you, each of you who has your gadget, try to open Google, type summer, look for images, and then we are going to share the images together to describe.
I found it.
Great, you found it. So, but wait, let us pause a bit. I want to give an opportunity to everyone to find it. So thank you. I'm giving you 2 minutes. Find the images. I'll allow you to share the images of summer, and we use that to describe what the weather is like in summer. Thank you. I'm going to pause for 2 minutes for you to find them. Thank you.
I'm supposed to add.
You're muted.
I'm allowing you to share your screen. Who will go first? Who is going first? Put up your hand, then I let you share your screen. Okay, this is Marilyn. Let's see, Marilyn, you came first. Okay, Marilyn, share your screen. We see what you found out. Wow. Are you able to tilt your phone to make it landscape? It might show the images better when it is landscape. Yeah, I think that one is better. Okay.
Not technically. It's best to use a laptop.
Best to use a laptop, but we have a phone. We use what we have. Okay, guys.
I have a laptop, I can help.
Let her first show us as well. Great. So from this one, let us look at the images.
I have no idea at this point. Like,
what do you think the temperatures are like? Let us try to describe the weather in summer from the images. Okay, let's see.
my cable.
Franklin. Franklin, when you look at those images, what does summer look like to you?
It's dark.
Franklin, what does summer look like?
I think the weather is hot when it's summer.
So you think it's hot?
The sun is ever there.
Okay. So you think it is hot, it is sunny. Okay. Certainly not cold, according to this one. What makes you believe it is sunny? Franklin, you are saying it is sunny.
Teacher. Yes.
Yeah, because it is.
Because
summer.
Because.
Guys.
Katende, you want to tell us why you think it is sunny and hot? Looking at the images.
I think it's sunny because there are some certain parts of certain parts of the year, months of the year where there is more heat and the sun is up.
Okay.
Most.
And you said you've seen people with hats, did you say?
Yes, so that they can shield themselves from the sun, which sometimes is a lot.
Okay, so because you've seen people with the hats, you think, maybe it looks like it's sunny. They need to shield themselves, and probably some of them were bare-chested, some of them were running in the water, and that suggested to many of us that it is probably hot and sunny. And I agree with you. Now let's go back to it. When does it occur in the Northern Hemisphere, for example? So let's go back to the search like we did, and then we check when does summer occur in the Northern Hemisphere. So again, we are going to search. Let's see. Let me share my screen. Here is my screen. Then I open a blank window. I type Google, and then my question is summer. Great, and I press enter. Then it is telling me it is June 21st to September 22nd. And it is saying in the Northern Hemisphere. So it is saying in the Northern Hemisphere, it will be from June 21st to September 22nd. Therefore, I can infer that summer will take place in June, July, August, and September, 4 months. And these are 4 months in the middle of the year in June. So in the Northern Hemisphere, in Europe, summer will be in the middle of the year. On the opposite side of the earth, in the southern hemisphere, we will expect during the same time, we will expect to have winter. So summer, a time of hot temperature, of sunny weather, will take place in the middle of the year in the northern hemisphere, meaning that as we speak, because today we are in July, the northern hemisphere, your relatives in UK, in Norway, in Oslo, are experiencing summer. What does winter look like? That is our next question. First, we are looking at what is it like. So let's see. Let us now search for winter. Again, we'll go to the browser. I need you to type winter, and then one of you is going to share the images of winter. So let's go. Those of you who have just joined, we are enjoying a bit of geography. We are using the tools we have with us. We are learning about seasons. And we started by looking at summer. Now we are going to look at winter. So we are going to a search engine, Google. We are typing winter, and then we look at the images of winter. I see Shadia Karema's hand is up there. Shadia, if you've finished researching, share your screen and we see. So whoever is, share your screen, we see the images of winter. Great. Okay. Share slowly, don't move, don't scroll too fast. So these are images of winter. Guys, remember to mute yourselves. And today I'm not muting you guys. You have reached the level where you just manage yourselves. Okay, great. Winter. What do you infer about winter? What do you deduce? What can you say about the temperature and other characteristics of winter? What is it like? Based on these images, what is winter like? I need people's hands up to tell me. Maizun, you want to comment on that quickly? What is winter like?
Yes, teacher.
Yes.
It seems like winter is really cold to the extent that it like snow even comes and it does not melt. And so, I think the temperatures are below 10 degrees Celsius.
Okay. So you think the temperatures are way below 10 degrees Celsius? Esther, mute. Esther, you can mute yourself, and Purity. So Maizun thinks that it is really, really cold, below 10. We could probably even put it minus, so that it is minus below 0. Why am I saying below 0? Guys, when you look at it, why am I modifying Maizun's answer and I'm saying it is below 0? Maizun, I still see your hand.
Teacher, I think it's because, yes, I think you're saying it's below 0 because the water has turned to ice. So, and water freezes at 0 degrees Celsius.
Exactly. So I'm saying that it is certainly below 0 because we are seeing ice and usually water freezes below 0. So probably it is very, very cold. It looks like it is really cold. What else shows you that it is really cold? You've seen the ice. Have you guys seen the snowman left on the left-hand side? It says not a winter. On the left, no, it is there. It is, I see it in your picture. That one, they normally call it snowman, that one. Someone usually constructs it. It's one of the games guides they have. Just the way like here kids get dust and they make houses out of them. They are in winter, they do those things. So it is really, really cold. We could say it is bleak. It is not fun for many people. Huh? Sometimes the days are short. So you might have a day that is only 3 hours. Just 3 hours day. But deep at the southern hemisphere, at the poles, you have 24 hours of night, 24 hours of night. Meanwhile, at the poles in the northern hemisphere, you have 24 hours of day. So at the same time, on planet Earth, one hemisphere has 24 hours of day. It is hot and sunny. On the same planet Earth, at the same time, both receiving light and heat from the same sun. The other place is terribly cold. So we want to understand why. Before we go to that, I want us to confirm, because sometimes you say, Mr. Karima is a great liar. So let us go to Mr. Google. Type winter. We see what date it tells us. When do we have winter in the northern hemisphere? Great. From this one, what do you guys read? When shall winter be? Let me see. Ikazi, Natasha. Natasha, are you there? Natasha? Natasha.
Yes, teacher.
From this one, when do we have winter in the northern hemisphere? Natasha. Hi, Natasha.
Hi, teacher.
When is winter in the northern hemisphere?
In December.
It is in December. December to what? From what to what?
December 21st.
So from December to March. Yes, you're right, Natasha. Which means that we are going to have winter, December, January, February, and part of March. In the northern hemisphere, now guys, do you realize that Christmas is on 25th December? And 25th December, people here in Africa, they get a tree, they put wool on it, they get Father Christmas and they dress him in a huge woolen thing, who goes giving gifts here in Africa at this time in December when it is very hot. It is because where Christianity was, where they were celebrating Christmas, Christmas was in December at a time when it was very cold in December. So that was the culture. The guy would put on a huge thing. Now, the one who is sharing, this is Shadia. Search for us. When is winter in the southern hemisphere? Say winter in the southern hemisphere. We want to see winter in the southern hemisphere. When does it take place? Winter in the southern hemisphere. Don't move. In the southern hemisphere, they say here in the northern, winter is at that time. But we want to prove to ourselves when is winter in the southern hemisphere. But want to prove to ourselves. I'll leave that to you as an assignment, but as a hint, when you have summer in the northern hemisphere, you have winter in the south. You can now scroll through and see if you'll find the answer. Winter, you are saying, stop there. In the southern hemisphere, let me pick. Stop. Nakubulwa. Nakubulwa Ashura Hasure. The lady with the beautiful name. Let's answer it. When is winter in the southern hemisphere? Ashura. Hello, Ashra. Nakubulwa, are you there? Ashra, today I've got you. You are the one I'm talking to now. Ashra. Ashra is trying to unmute. I need someone else to put up the hand and tell me. Raise your hand. When is winter in the Southern Hemisphere? When is winter in the Southern Hemisphere? Maizun has the answer, but now I'm going to pick a different person. Another person who is ready. Maizun and Shadia are very active. So I am forced to pick another person. I see another one. Who is this one? I see Bushra. Okay, Bushra, go ahead.
I think winter is on the 20th of the 20th of June in the what? Okay, since you say that when there is winter in the Southern Hemisphere, then there is summer in the Northern Hemisphere. So we shall just have to like turn it around. Now when they ask me that, I would say the day winter is, let me just give the answer. It's on the 20th of June.
20th of June. Up to when? Because it's a season. So it will start on 20th of June. But it is a season. Being a season, it means it covers a period of time. So to what? Batambuze, Batamuliza, your mic is active. I am now asking you, Batamuliza. Don't mute. When is winter? This is how I check whether you have been following.
I have just
okay.
changed.
Oh, okay. Okay. So, Maizun.
Yes, teacher.
When is winter in the Southern Hemisphere?
I think winter starts from 20th June to around 20th November or 21st November.
Okay, so it's a season. It is the opposite. Marilyn, you're most welcome.
Yes,
Marilyn,
teacher.
when is winter?
Yes, teacher. In the Northern or the Southern Hemisphere?
In the Southern Hemisphere. Is Maizun
but
right?
But Maizun just mentioned. Yeah, I think
right?
she's right. Yes.
Maizun, you have
Still,
survived.
I'm asking in the Northern Hemisphere.
Okay. So, stop share. Let me now summarize it here. So let's see. Let me try to share my screen. Now we see if it is correct. Okay. But even if I don't share my screen, you guys have nailed it. So I had picked those two images to indicate summer. And from it, we said that it is hot and sunny. That one we agreed. And it occupies the months of June, July, August, and part of September. June, July, August, and part of September. Then this side, it has, it will be summer in the Southern Hemisphere in the months of December, January, February, and March. Then we go to winter. And winter, again, we said, in the Southern Hemisphere, in the Northern Hemisphere, winter will begin from December and will end in March. So it has December, January, February, and March. Winter in the Northern Hemisphere is December, January, February, and March. In the Southern Hemisphere, winter will be at the first time. Now, I want us to talk about two others. One is autumn. Please mute. Please mute. One is autumn, the other is spring. 2 seasons, autumn and spring. Mute yourselves, mute guys, autumn and spring. Okay, so autumn. We could use the same method of you finding out, but probably this time I could just play a short video that talks about autumn quickly. So a short one that summarizes autumn season. I think it's this one. Okay, wait a minute. Someone said the laptop is better. I am about to disagree with you because my laptop has just frozen. So let me give it a minute. But like we said, when one tool is failing, we use the other one. Why don't you search for autumn as my machine wakes up? Autumn.
Teacher, found it.
Found it. Great, share it with us.
Yes.
This computer of mine was thinking that you guys are not there. You have proved it wrong. You have proved my machine wrong.
Can you see my screen?
Wow. Let us try to describe what we are seeing. What are we seeing?
Teacher, I can see that the leaves are a bit orangish and yellowish in autumn.
The leaves are orangish, or brownish. We could say falling.
They are what?
Falling.
Yeah.
What else? Nazneen. What are you seeing?
Yes.
Nazneen, go on. What are you seeing? Describe what you're seeing.
I see leaves falling because in autumn is basically preparing for winter, and I see reddish brown leaves.
Okay, reddish brown leaves. They seem to be dying. Like the trees are losing their leaves. They are more or less drying up. Trees are losing them to prepare for winter, because if they still have the leaves and the snow falls on them, the branches will become very heavy and the branches will break. So in nature, they live. So because the leaves are falling, some of you could have heard people say, in the fall, we shall do that in the fall. What they mean, they'll do it in autumn. They'll do it at a season when leaves are falling. That is the autumn. So let's scroll further and see what else is there. Okay, continue.
Teacher, I also found that autumn is the transition from summer to winter in September or March.
So it is a transition. Number 2.
From summer to winter.
From summer to winter. What is the temperature like? So I agree with you. It's a transition from summer to winter. It is preparation for winter. But what is the temperature like? I'm going to give you a number of words. Is it hot? Is it warm? Is it cool? Is it cold?
It is cool.
So it is cool. You could say it is cool. I would say it is warm, but with every passing day, it becomes cooler and cooler until we go to winter when it becomes cold. So the temperature is decreasing. It is declining day by day. That is number 1. So temperature declines from warm to cool, eventually to cold.
Teacher, can we say that it is decreasingly cool? Because
That
it
is,
keeps on
that is increasingly cool?
Decreasingly cool. Because the negative degrees, you know, are not, I can't say that they're increasingly cool. So I have to say they're decreasingly cool.
You can't say it is decreasing.
I can't say it's increasingly cool.
Maybe you can say it becomes cooler and cooler by the day.
Okay.
But I would prefer calling it increasingly cool. Like every day it moves to being cooler and cooler. But we will find an appropriate word.
Okay, what if we say that there's a temperature drop every day?
So the temperature drops
daily.
Daily. So it becomes cooler and cooler by the day, right?
Yes.
So the temperature has become cooler. That is the main message. Temperatures become cooler. Now, if you're writing, if you have a notebook, this would be a very good time for you to take note of those things. So one we have seen in terms of the appearance, in terms of weather, it moves from being warm to cooler. Temperatures become cooler by the day. Number two, how about the length of day? We said in some places in winter, the day is very, very short. In summer, the day is very, very long. How about in autumn? The days become shorter because you're moving from summer, where the days were very long, to winter. So the days become increasingly shorter. Like we are saying, so they become shorter and shorter by the day. That affects the plant life and animal life. Everything is preparing for winter. I need us to check, when does it happen? So this time, don't search for the images. I need us to go to YouTube and we type autumn. There is a video that I think is very good for showing what autumn is. So go to YouTube, then we check autumn. What is it like? I think I saw when I was doing some research, I saw a nice video on autumn. Very, very beautiful. I loved it. So let's see. I really would love you to enjoy that little video. It was nice. I liked it. I hope you like it too. Who is searching for it? Who is searching for that video about autumn? Good. I have it here. Let me post the link and I see if one of you is able to play that short video. You know, teaching your class is wonderful because you guys are so able. You are so able to do things on your own that, I mean, you enjoy the lesson yourself. So let's see. I'm sending you this short video that I've seen. This one. I'll put it in the chat room. Who has a laptop who can play it very, very well? That video. Purity. Do you have a laptop? Purity?
Yes, teacher.
Have you been able to see that link? Let's see. Are you able to play and show it to us?
I've seen the link. Let me try and access it.
Exactly. Wonderful, Purity.
And that it's getting darker earlier? That's because autumn is here. In most of North America, we have 4 seasons: winter, spring, summer, and fall. fall is also called autumn, and autumn can bring big changes. In autumn, the temperature outside gets cooler. We trade in our shorts and sandals for clothing that will keep us warmer, like jackets, hats, and scarves. The cool autumn weather is a perfect time to go to a pumpkin patch. Autumn is the only time of year that pumpkins are ripe and ready to pick. Autumn is also the season when the leaves on many trees change from green to bright yellows, oranges, or reds. Leaves that change color are usually broad and flat. Why do these leaves change colors? In the spring and summer, the weather is warm and the sun is bright. Leaves make lots of chlorophyll. Chlorophyll is green. Leaves have other colors inside, but the green chlorophyll blocks out the other colors, so we don't see them. In autumn, leaves stop making chlorophyll. Then, the other beautiful colors inside the leaves show through. Soon, brown and fall off. Then in winter, the tree's branches are bare. But not all leaves change colors. Evergreen leaves are always green. Evergreen trees often have needle-shaped leaves like these or these. And no matter what the season is, evergreen leaves are always green. Autumn is a season when animals are very busy. Food is easy to find, so animals, like squirrels, are busy gathering mushrooms, seeds, and nuts. When winter comes, everything will be covered in snow. Food will be hard to find. But squirrels won't have a problem. They hide a lot of food in autumn and will know exactly where to find it. Autumn comes around every year, and you'll know when it's here. All you have to do is look for the busy squirrels, the colorful leaves, and funny pumpkins. Hello, Autumn.
Wow, so thank you. This is what I saw from the video. That, no, why don't you summarize it? Why should I be the one to do it? I was becoming the teacher who shares things alone. So I need the summary. Who is going to summarize for us? What did you see? What does autumn look like? And we want to write a summary, a quick summary. At the hand of Puri. Okay, Marilyn. Oh, Marilyn, you answered the question today, right?
Yes, I did.
Let's see if I can get, let me see if I can get another person who hasn't yet answered the question. If you haven't answered the question today, this is your opportunity. Who is that? Franklin has just shared for us. Okay, Franklin, go ahead. What did you see? What is your summary of autumn?
Well, autumn, I saw that in autumn, it's cool and cooler, gets cooler and cooler every day.
Okay.
Food is easy to get.
Okay. For wild animals.
And the leaves of the trees, they change in color as the day goes on.
The leaves become brown.
Yes.
And the days become shorter. I agree. Thank you very much for that summary. Marilyn, you wanted to add something?
Yes.
Add it.
She said that autumn is the season where pumpkins are a lot or there are many. It's the season where pumpkins are most ripe. So that's all.
Let's now finally go to spring. Spring will be a very quick one. That's another season. Spring, what does it mean? Let's use the same method quickly. Let's go to Google. We type spring and then search for it. My class has many people. I want to see Chirabo, Megan. Megan, are you there? Megan? Let's search for spring. Okay, I see Cheryl. Are you there?
Yes, I am.
Are you able to search?
Yes.
You know why I'm picking? Okay, you search. Because the two people who are ready have already searched. I want you guys to be involved. And I'll be picking on different people. So what have you found, Cheryl?
I searched on what?
On spring. Cheryl, search on spring. You are our king today.
It shows the following.
Okay, Cheryl. So number one, Cheryl, don't go away from that screen because I think it's a beautiful one. It has very good information. Could you remove this thing which is covering the left-hand side of your screen? You can grab it and move it a bit. Because I want us to be great. I want us to read this little part which says spring season. First, we are saying from 20th March to June. Let us read that little part. Spring, also known as, read it for us. Somebody is writing on your screen.
Spring, also known as springtime, is one of the 4 temperature seasons succeeding winter and preceding summer. There are various technical definitions of spring, but local usage of the term varies according to local climate, cultures, and customs.
Okay, this is what I've picked from here. It is saying it is a season succeeding winter. Succeeding winter that follows, it says it follows winter. And preceding summer, meaning it is before summer. So it is between winter and summer. Now, in the Northern Hemisphere, if you recall, we said summer ends on 20th March. So from March to June, that period is what we are calling spring. In the Northern Hemisphere, in the Southern Hemisphere, it will be different. The time for winter for autumn in the Southern Hemisphere will be the time for spring in the Northern Hemisphere. Now, I need you to tap on images. Don't scroll. Just where there's a search bar there, let's look at the images of spring. Okay, let's scroll through them quickly. What is spring like? Spring. We saw autumn, leaves were falling. How about spring? What is it like in spring?
To me, spring looks like when flowers are growing and birds are out.
Yeah, the flowers, plants are flowering. remember they were in a very dull, cold winter. Now they are flowering. Tell me, what does the temperature look like? Is it becoming warmer or cooler, in your opinion?
Warmer.
Looking at this.
I think it's becoming warmer because you can see the sunshine, like in this photo.
Yeah. So it is from the photos, we are seeing that it is becoming warmer. The leaves are coming on. The tree,
and animals are coming back.
The animals are coming back. It's like life is springing back. Plants are springing back to life. You see that?
And here they said this is the season of hope.
So the season of hope when things get better. Guys, I remember I was in Norway for a couple of months in winter. Now, for me personally, I don't usually appreciate flowers. But after winter, spring came, and then there were these flowers. And for the first time in my life, I saw flowers and I felt so joyful because it was like a promise. Life was, I really felt so happy. That's when I realized why Europeans love flowers. Because here, when I'm here, everywhere I look, I see flowers. I don't mind. But that day, when the flowers came out, when you see new buds, new leaves, when the birds start singing, it is bright, it is hopeful, it becomes warmer every day, you're moving into summer. So those are the seasons. My greatest question now that we know the seasons, can we summarize? You can stop sharing now. So I want us to summarize quickly. If you have where to write, we could write there quickly. If you have a pen, this would be a great time for us to make some quick notes. Some quick notes together. So we are saying for autumn, also referred to as fall. You said temperatures falling.
Keep on decreasing by the day.
Declining or decreasing by the day. Then you told me. It
is a transition of summer to winter.
Transition from summer to winter. That one you told me.
Yes.
Then you
the
said
days become increasingly short.
The days become
are short and nights are
increasingly
shorter.
In the Northern Hemisphere, I hope we are making notes together.
Yes, teacher.
Hemisphere, it occurs from, from to, I don't remember. Great. This was what? Autumn. If I pronounce it like an African, that's cool. So, and where did I put it? Here. Then we talked about winter. I hope you made some brief notes on that as well, where we said that winter is very cold.
Yes.
Did we say very cold season?
Yes.
Temperatures falling below 0 degrees Celsius. So there is freezing, not so? There is ice.
Yes.
And snow. Then we say the days are very short.
Yeah.
Sometimes 24 hours of day, not so? 24 hours of darkness.
Of night.
Or of night. Great.
We also said it begins from the 21st December to 20th of March.
Okay, so it begins from
The Northern
December,
Hemisphere.
from 21st December. So from December,
21st
January.
December to 21st of March, 20th
of March.
So
in
21st
the Northern Hemisphere.
December.
Yes, in the Northern.
Did you say to 22nd?
To 20th March.
So winter from December, January, February, March. To be specific, 21st December to 20th March. I think that is a good summary. If we are writing, we have written it properly, haven't we? Great.
We haven't included the Southern Hemisphere.
Hey, in the Southern Hemisphere. So what is it like in the Southern Hemisphere? This one is in the Northern Hemisphere. In the Southern Hemisphere, when is it? Remember, it occurs at the time when we have summer in the Northern Hemisphere. When is it? This is how I do it. I instead
the Southern Hemisphere. It starts 20th or 21st June.
June to
mid. No.
It's around September. The ending date, I'm not really sure.
So it said 21st June to around 20th, about 20th September. I'm going to confirm this. And how do I confirm it? It is by looking at, this is in the Southern Hemisphere. How do I confirm? It is by looking at the same time for summer. So we go to summer. We said, what is summer like? It is hot.
Hot and sunny.
Warm. It is sunny. Okay. It has long days. It has short nights, not so? Yes. And in the Northern Hemisphere, it is from what date? If you recall. Summer was the first one we did.
From June to part of September.
June to part of September. September. So this one is in the Northern Hemisphere. This is the same date for winter in the Southern Hemisphere. Great.
Teacher, there is, okay, according to Google, summer in the Northern Hemisphere is, okay, like it says, depending on the shift of the calendar,
okay.
The summer solstice occurs sometime between June 20th and June 22nd in the Northern Hemisphere and between December 20th and December 23rd in the Southern Hemisphere. The same dates in the opposite hemisphere are referred to as the winter solstice. It does not give like the ending time of the season.
Okay, it doesn't give the actual end time for the season. And the reason is that even though the Northern Hemisphere is huge, it is not always at the same temperature across. Secondly, the Earth rotation takes 365.25 days, not 366. So we normally round off and have a leap year. And because of that, we do have sometimes saying it is 21st, another time saying it is 22nd, because it is not always 366 exactly, no. So we do have those differences. But the point is made, In one quarter of the year, we have this. In another quarter, we have a different one. Why? Let's watch this short video that explains why. Why do we have these things? It is a 5-minute video. It is short, but I'm afraid my machine is freezing for some reason. Why does it freeze? Please, computer, don't freeze on me. I wish I had frozen when I had already given the link, but no problem. These things here, when the computer tries to play tricks on you, you also increase your game. You play other tricks on it. So I'm going to show this short video. Stop share, then share. Share, share sounds. Great.
How long does it take the Earth to make one complete rotation around its axis? 24 hours or 1 day? If we look at the same image of the globe, but from the top, looking down the axis from the North Pole, we see the Earth is rotating counterclockwise around the North Pole. If we look more carefully at this axis of rotation, we see that it is tilted relative to Earth's orbit around the Sun. Instead of being perpendicular, it's tilted 23.5 degrees. How long does it take the Earth to make one complete orbit around the Sun?
This person is saying, how long does it take the Sun to make one complete rotation, one complete revolution around the Sun? The Sun is here. You have the orbit. You have this one rotating. I need you to see the first part that this key that was here, right here. The Earth tilts. This tilt, we call it the axial angle. This is the axis, if you recall. You have your Sun right here, hitting. Ladies, please be observant. If the Sun, can I point? Can I point? I think I can. If the Sun is right, if the axis is right here, this is our axis. At one time, when the Sun is like this, it will light this entire part of the southern hemisphere. This one, the whole of it.
It's tilted 20.
But at the same time, if we took a line, we put a line right here. I want to annotate. And I want to annotate with the, let me see, correct, yeah. I think I can annotate like this. Yeah, I think I can. Very good. I can annotate. Guys, if you look at this one, if you have the sun's rays right from here, they can hit this part. This part will be showed. This will be right here. This will be heated. You'll see it. This will be heated. So the sun's rays will be directed to this area. Now this pole of the south, this one, which we are seeing here, is bright all the time. So even if the earth rotated on its axis, this part will always have light, whether it is day or night, because no part of this pole is hidden. But let us look at the North Pole. At this very time, what is happening in the North Pole? This is our North Pole. Now look at the sun's rays. They stop here. This one is hidden. I've drawn this line which shows day and night. This North Pole at this time is in a shadow. Then you have night here all the time. Whether the earth rotates on its axis or not, at this time, you do have night. Remember when we said in winter, you have night 24 hours. This is how it happens. In summer, at a particular time in the southern hemisphere, or in the northern hemisphere, you have winter. In summer, you have 24 hours of day. This is how it occurs because of the axial angle, because the earth is tilted away. Let me clear these things, clear all drawings. Let's move. I stop annotation. How? Let's first continue. Let's
3.5 degrees. How long does it take the Earth to make one complete orbit around the Sun? 365 days, or 1 year. During Earth's orbit around the Sun, it follows a nearly circular path, but with a small elliptical
Ladies, I need you to pay attention to this as the Earth moves around the Sun. The inclination, this one, the axial angle is the same, but when the Earth moves to different locations, one part of the Earth is shown. One pole is more exposed than the other. Let me pause a minute and read the chat room before I proceed. She means work, please send. Okay, guys, I've seen the issues you had, so let's continue. I was only pointing out, as it revolves around the Earth, I need you to pay attention to which part is tilted towards the Sun. So let's look at it again.
Or 1 year. During Earth's orbit around the Sun, it follows a nearly circular path, but with a small elliptical eccentricity. The Sun is not in the center of the ellipse, but one of the focal points. Bottom line, the Earth is a little closer to the Sun every January and a little further away every July. Does that cause us to have seasons? Let's think about it.
Okay. Fact. The Earth, the distance of the Earth from the Sun varies. At one point, the Earth is nearer to the Sun than another point. In January, the Sun is nearer to the Earth. Sorry, the Earth is slightly nearer to the Sun than it is in July. And the question she's asking is, does the changing distance account for the seasons we have seen? Is it the distance that causes the seasons? Because some people believe it is the distance. And she's saying, maybe, maybe not. Let's wait.
We'd expect the planet to be a bit warmer overall when we're closer to the Sun. When does that happen? January. Is that our warmest season in the Northern Hemisphere? No.
Okay. She's refuting it. She's saying, guys, don't even mention it. Because in January, the Sun is closer. The Earth is closer to the Sun. Like the Sun would ideally be here. But that is not the time when we do have hot temperature. So it cannot be the reason. Because in January, in the Northern Hemisphere, we surely have some winter. So she's saying, no, that is not the reason. What is the reason?
So the seasons must result from something entirely different. Let's return to the tilted axis of the Earth. As the Earth orbits the Sun, it goes through 300 and...
I'm pausing a bit. Are you able to hear clearly?
Yes, teacher.
Yes, we are.
Okay, so let's continue. Now, we have the diagrammatic illustration. And at this time, I want to pause. Let us look at this diagram. Study it carefully. The Earth's tilt is the same at all times. It is tilted like this. Last time we said it is at an angle. From the vertical, it is an angle of 23.5 here. From the horizontal, it's an angle of 66.5.
66.5.
Now, look, here is our Sun. Here is the path. Let's see, when the Sun is right here and the Earth is here, you see the Earth, this part is being heated. This face is heated. It is facing the sun directly. So is this one, when the opposite side. So here, and if the sun is right here, I mean the earth is right here, all the parts of the earth are heated equally. No part is hidden because the axis is here. So the North Pole will be heated, the South Pole will be heated equally. How about when the earth is at this position right here? I hope you are seeing on my right-hand side, this one.
Only one side will be heated.
So if you look carefully, the northern hemisphere, let me now use the annotation tool, and I show. I'm going to draw a vertical line, the vertical line. Why do I draw this vertical line? Because when the sun's rays come like this, I should be able to tell where they end, like that, like this. When the earth is at this position, this is what you are seeing. This part here, this one, this is hidden. This North Pole is away. So this part is going to become very cold. But let us look at the southern part. The southern part here, the poles here is exposed. This is the southern pole right here. All of it is exposed. It is heated. So 24 hours right here in this position. Let me erase. Let me erase. Have I erased? Boom, boom. No, I have not. Guys, clear all drawings, great. Let's now look at the opposite side. Look at this one now. When the earth turns and is on this side, remember it not turns, it revolves. When it is revolving, when it is revolving, it goes to this side of the sun. Now, things change. This time it is the northern hemisphere that is facing the sun 24/7. And I'm going to use annotation. Let me go and I check annotation. Where is it? No, I have not seen it. So let's first continue. Okay, wait. June 22nd, solstice. Solstice, June 22nd. And after this, you're going to answer the questions in the learner's book. Let's see what happens in June. June, middle of the year. You guys said June in the northern hemisphere. You told me middle of the year, it is summer. What happens? Let's check. This is our thing. Don't rush. We still want to finalize this one. Don't rush, my friend. In June, the North Pole is facing towards the sun. Now I am posing which part of the earth is experiencing summer. Let me see. Put up your hands. Which part of the earth from this diagram is experiencing summer? Raise your hands from this diagram. Marilyn, great. Which part of the earth is the northern? You said northern hemisphere. So what is in the south?
Yeah. Right now, if we were today, I drew the line, and so I saw the northern part was the one experiencing summer, and the one where the sun does not reach will be the one, I think, experiencing winter.
Exactly. So, by the way, are we recording or not recording?
We are.
Great. So we are saying solstice. In the northern hemisphere, it is summer. In the southern hemisphere, it is winter. And the reason for that is the southern pole, the South Pole, is tilting away from the sun. Now we are seeing those cold temperatures that we are referring to. Remember the pictures you saw, and then you remember the warm weather we saw in the pictures. Now it is beginning to make sense.
Yes, teacher.
Yes, teacher, it is. So I have a question.
Okay, if you have a question, let me pause so that we answer the question. Correct.
Teacher, in the diagram, I'm seeing only winter and summer. I'm not seeing any, okay, I'm not seeing like how spring comes in and autumn.
Okay, great question. Very good. You are seeing winter and summer because we are still on our journey. Our journey has started with summer on this side. We have gone to winter on this side. But when we go to these other quadrants here, this one and this one, that's when we shall be talking about the autumn and spring. So we've started with the extremes, and then we shall slowly go into the middle zones, the transitions. Remember, we called them transitional period, that it is in between summer and winter. So we shall come to this. So let's see them now. Okay, this person has put the sun here for illustration purposes. And for illustration purposes, we are drawing this line and showing clearly that this part of the Earth, the North Pole, is facing away from the sun. So it must be winter, and that is in December. Meanwhile, in the Southern Hemisphere, it is being heated all the time. So this must therefore be summer, and that is in December. The opposite side is in winter. So let's continue. Now, the equinox, equi comes from equal, equinox, equal day and night. The sun, the earth is tilted. Fortunately for the earth, the tilt is not away or towards the earth. So at this time, even though there is a tilt, the whole part of the earth is exposed. Or both poles are exposed. We call this the equinox. Equinox. And these are the times, this is the intervening period between summer and winter. These are the intervening periods which we have baptized autumn and spring. Let's continue.
Excuse me, teacher.
Okay, let me go back a bit. We are saying at this time.
Excuse me, teacher.
Yes, please. Ask your question.
I'm only seeing that, okay, I'm not seeing anything change. Like I'm seeing the other diagram you left of Earth rotation, the sun and the... And the winter, I'm not seeing anything else.
Okay. I'm going to write on the screen to see if we are seeing the same thing. Are you able to read March 22nd here?
No.
Really? Let me stop sharing and share again. Let me also read the. Hey, I can't see anything. Let's see. I share. Are you, what do you see now?
Now I see March 22nd equinox, June 22nd solstice, and September 23rd.
What were you seeing before?
The background.
But now you're able to see.
Yes, now I'm able.
Okay, let me, okay.
You couldn't see it clearly.
You couldn't see clearly. Okay, let me check. Because it is not. I'm going to be monitoring the chat from here. First of all, before I go deeper, I want to be sure that we are seeing. Let's see.
How long does it take the Earth to make one complete rotation around its axis?
Now,
24 hours.
I need to see if you are able.
If we look at the same image of the globe, but from the top, looking down the axis from the north.
Are you able to see the globe and the North Pole?
Yes, teacher, we are.
Yes, teacher.
Yes, teacher.
All of us, right?
Yes.
Okay, let me play it now.
Pole, we see the Earth is rotating counterclockwise around the North Pole. If we look more carefully at this axis of rotation, we see that it is tilted relative to Earth's orbit around the Sun. Instead of being perpendicular, it's tilted.
This is the tilt that I was referring to. This is the tilt I want to annotate here so that it doesn't take us a lot of time. Annotate. Annotate, okay. This is what I'm doing. I'm drawing a vertical line right here. And I am saying, because this concept is what is going to come all through. The sun revolves around the earth. But as it does, there is a tilt. And along this tilt, it keeps on rotating, it spins. Now, when it revolves around the earth, the shape of the tilt or the angle of the tilt remains the same. But one part of the earth will be exposed at one time and another tilting away. When it is in a position such as this one, these sun's rays will hit this part here. And when the earth spins, remember the spinning, the rotation is what causes day and night. When it is here, even if it started spinning, the sun's rays would still be able to light up this part. So the southern hemisphere would be day all the time, 24 hours day. The sun's rays will still be hitting it. I was privileged to be in Norway at a time when they had 24 hours of day. So I was there, 6 p.m. day, 10 day, midnight day. You might ask, how did you sleep? You put curtains 24 hours day.
Teacher, in the UK, the sun used to set at 10 p.m. at night.
So in the UK, sometimes you could have a long, very, very long night or a very long day, right?
Yes.
Yeah, so it can happen.
Set at
10. Now, meanwhile, this place here in the northern hemisphere, at the poles, when it is heated, the sun's rays are here like this, they never light up the North Pole at that season. So from morning to night, from morning to evening, it is night. So if you're Muslim and Ramadan finds you there at this time, my friend, you are covered. Because it is 24 hours of night. If they say you're fasting during the day, so you might ask, how do they fast? It is this angle here. This angle tilts. It is called the axis. The earth tilts away. So when the earth is in a particular location in the orbit, one part is exposed because of this tilt. That is the message that we are seeing today. And we are using it to explain winter and summer. We are using it to explain, and we are calling those periods the solstice. And then we have a time we call the equinox, when we have equal day and equal hours of night. Clear all drawings and proceed.
Teacher.
Yes, please.
In Uganda currently, I think our days longer than our nights. So what season is this currently in Uganda?
Great question. So in Uganda, do we have those things happening where we have long days and long nights at some point? No.
Yeah.
The reason is, what is the reason?
Uganda is not in the southern hemisphere, and it's also not in the northern hemisphere. It's at the equator.
So Uganda is right here at the equator. So no matter how it spins, we are still in direct sunlight, direct heating. So for us, come day or shine, we have our 24 hours, 12 hours of day and 12 hours of night. It shifts a little by a few minutes. Those of you who are Muslims know in Ramadan, at some point they tell you, today you're breaking the fast at 6:59. On the other day, you're breaking the fast
at 6:59, sometimes at 6:57, sometimes at 6:50, sometimes at 7. It keeps on alternating.
Yes, but within a few minutes.
Yes, within a few minutes.
Imagine the earth starts turning in a different direction. What would cause that? Yes.
So now just imagine you are in a Kamunye, you are headed to Masaka at 64,000 kilometers per hour. And then they stop the Kamunye and it is supposed to speed in the opposite direction at 6,000 kilometers per hour. The question is, what would happen? That is what would happen. So if it were to stop spinning or even spin in the opposite direction, then you know that is the day of Qiyam. that is the real day. By the way, I suspect it will happen.
Yeah.
So now let's continue.
They said that the sun will rise from the west and set in the east.
Meaning we will move. Oh my God, the earth will rotate. The earth.
So let's now
revolve around the sun from east to.
So let's give it a minute, 2 minutes now. I'm not going to interrupt, and then we see the animation. Now that we have discussed it a bit, okay. Let's go.
23.5 degrees. How long does it take the Earth to make one complete orbit around the sun? 365 days, or 1 year. During Earth's orbit around the sun, it follows a nearly circular...
Now, because you said you are not able to see earlier on, I want to repeat this. When the sun is in this position, when the Earth is in this position, you are seeing This is the tilt. This part, the North Pole, is away, tilted away, whereas the Southern Pole is facing the sun. You're able to see that. I'm repeating it right here, just a little bit here so that you see it. That position. That position. You see? You have been able to see when we look at this clearly. Look at it.
365 days, or 1 year. During Earth's orbit around the Sun, it follows a nearly circular path, but with a small elliptical eccentricity. The Sun is not in the center of the ellipse, but one of the focal points. Bottom line, the Earth is a little closer to the Sun every January and a little further away every July.
This is what we said earlier, that at some point, the Earth is slightly closer to the Earth, for example, in January, and at another, it is slightly further from the Earth. And we agreed that whereas it is nearer, it is not what is responsible for the seasons.
Does that cause us to have seasons? Let's think about it. We'd expect the planet to be a bit warmer overall when we're closer to the Sun. When does that happen? January. Is that our warmest season in the Northern Hemisphere? No. So the seasons must result from something entirely different. Let's return to the tilted axis of the Earth. As the Earth orbits the Sun, it goes through 365 daily rotations, while the axis maintains its tilt. On the June 22nd solstice, the tilt causes the North Pole to face towards the Sun.
Okay. June 22nd solstice, this one I have seen already. This tilt, the Sun is tilted like the Earth is tilted, and so this part, the northern part, is heated all the time, whereas the southern part is facing away.
While the South Pole faces away. When the Earth's orbit takes it all the way around to the December 22nd solstice, the North Pole is now tilted away from the Sun and the South Pole towards.
Now we are looking at in December, the Earth is tilted, the North Pole is tilted away from the Sun, so there is winter here. That's why we saw in the pictures in the Northern Hemisphere, it was winter in December. Meanwhile, it was summer in the Southern Hemisphere.
This tilt explains why the North Pole experiences winter in January, while the South Pole is experiencing the opposite.
Now we are basing on this diagram, showing the sun and the rays. This dark zone shows the sun's rays hitting. So this area here of the Northern Hemisphere right here is facing away, and it is very cold, winter. Remember Father Christmas? Remember those plants, the cold? Yes, so that is the time. When this Earth is on the opposite side, this side here, a different thing happens. Remember, the axial angle or the tilt is the same. So in June, then the Northern Hemisphere is exposed while the Southern Hemisphere is facing away. Now, someone said, draw diagrams to illustrate or to explain the occurrence of summer and winter or the seasons. The diagrams are here. They have been drawn already. I think I'll share with you this link, then you watch it in your free
summer. The North Pole is facing away from the Sun and gets less overall sunlight. The South Pole is facing towards the Sun and gets more. To understand this more fully, let's look more closely at how the Sun's rays hit the Earth. First, notice that halfway in between July and January, during the September 23rd equinox, the tilt causes neither pole to face away or towards the Sun.
Now, in the middle of the year, in the intervening periods in March and in September, the tilt is neither away from the Sun nor towards the Sun. So the Earth is being heated equally. This is when we do have the 12 hours of day and 12 hours of night on the day of the equinox. But after that date, you'll have increasingly shorter or increasingly longer periods. But at that point of 20 seconds, throughout planet Earth, you have 24 hours of day, 24 hours of night on all places on planet Earth.
Sun. As the Earth rotates every 24 hours, each area of Earth's surface will receive 12 hours in view of the sun and 12 hours out of sight of the sun. 12 hours of day, 12 hours of night. Equal lengths of day and night is why this time is called an equinox. As the sun's rays hit the surface, they are strongest at the equator, directly in the middle, where they hit at a 90-degree angle. As Earth moves towards the December 22nd solstice, the North Pole tilts further and further away from the sun. At its maximum tilt on solstice day, the sun's rays are now hitting directly at 23.5 degrees south latitude, or the Tropic of Capricorn.
Okay. Now, you guys, you've heard of the Tropic of Capricorn, the Tropic of Cancer, and we are arguing that at this time, it is 90 degrees at the Tropic of Capricorn, because at that time, remember the Tropic of Capricorn is 23.5 degrees. So when do we have perpendicular heating? At the Tropic of Capricorn. Let me rewind just a little bit. Pay attention.
North Pole tilts further and further away from the sun. At its maximum tilt on solstice day, the sun's rays are now hitting directly at 23.5 degrees south latitude, or the Tropic of Capricorn. Notice that every location within the Antarctic Circle at the South Pole is getting 24 hours of sunlight. As the Earth rotates,
24 hours of sunlight. This diagram is what we are enlarging, because you see here, right here, 24 hours, no jokes here. 24 hours of what? Of sunlight. So this is the diagram that is being enlarged. Yes, please.
What about the daylight saving time?
Daylight, That is a discussion of another day, but let me write it. Daylight saving time. That is a human adjustment to ensure that people don't run mad, but we'll discuss it further. The daylight saving.
None of these locations is ever lacking in sunlight. This creates the summer season for the southern hemisphere. In the northern hemisphere, inside the Arctic Circle, the reverse happens. 24 hours of darkness, winter season for the north. As we watch the Earth continue its orbit, the Earth's tilt again moves towards the sun, such that when we reach the March 22nd equinox, we once again have all parts of the planet receiving equal amounts of sunlight and darkness.
Equinox, are we able to see the equinox properly now? It is, the Earth is right here, the tilt is here, but there is nowhere to hide. Every part of the Earth will receive equal amount of sunlight.
The equator once again receives the direct sunlight. At high noon, the sun would be directly overhead here. Returning back to the June 22nd solstice, we see the tilt move the North Pole towards the sun, so that the North Pole receives more and more hours of sunlight each day. At the solstice, the Northern Hemisphere experiences summer. All points within the Arctic Circle experience 24 hours of sunlight, and the sun is directly overhead, providing its most intense heating at the Tropic of Cancer, at a location 23.5 degrees north of the equator. As we continue to watch this process, we can see that the Southern Hemisphere moves through this one-year orbit from its winter through its spring, summer, fall, and back to winter, while the Northern Hemisphere experiences the opposite season. Note that each solstice and equinox represents opposite seasons in opposite hemispheres. The winter solstice in the Northern Hemisphere is the summer solstice in the Southern. That means that sun lovers can plan trips to maximize their sun exposure, traveling to the Southern Hemisphere in December, January, and February, and the Northern Hemisphere during June, July, and August. And if you're looking for the most intense sun on the planet, Be sure to travel to the equator at the equinoxes, 23.5 degrees north in June and 23.5 degrees south in December. Pause now.
Okay. So, why not end it here? Have we answered our question?
Yes,
Why
teacher.
do we have day and night? Why do we have seasons at the time we have them? How does the rotation of the earth affect it? How does the axial angle affect seasons? How does revolution affect seasons? Would like to thank you for today's lesson. I think the question has been answered. I want to share with you this link so that you can take your time to watch it again. So I'm sending, when you go to Google and you search for seasons, you'll be able to get it. But let me share with you the link such that you can be able to save the link and use it at a time and use it when you want. I didn't put this particular link. I hadn't found it before, but when I did a little more research, I found such a beautiful link. So that is the link. I'll put it in the platform. Here is our work. Go to the prototype. There are questions in the prototype. Try attempting them. There are exercises. I think we've handled them very well. Look at the activity of integration. Try it out, because next week we are moving to the next topic, and that is climate and weather. That is what we are moving to next week. I want to check if there are questions that need to be handled. Otherwise, thank you very much. If there are questions, comments, I would love to handle them. I'll be uploading this video so that your colleagues who have missed the lesson can be able to watch it. I'll upload it shortly today so that others can be able to use it. Thank you.